Hi everyone, myself Bidyulata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is my 31st video lecture on the course Applied Artificial Intelligence. Today I am going to discuss about the topic Neuro-Fuzzy Systems. These are the topics to be discussed. First, I will introduce what is the meaning of Neuro-Fuzzy system. Then I will define what is the difference between the fuzzy system and why it is required, what is the need of neural networks, and what are the components of neural networks. Then what is the meaning of Neuro-Fuzzy system, what it constitutes, and few key concepts and the working of Neuro-Fuzzy systems, different types of models of Neuro-Fuzzy systems, as well as few applications of Neuro-Fuzzy systems. This is the topic learning outcome for Neuro-Fuzzy system. So after the completion of this topic, students can understand the fundamental concepts of Neuro-Fuzzy systems to solve complex problems. In my previous videos, already I have discussed regarding the fuzzy systems, introduction to fuzzy system, why fuzzy system is required. Even I discussed what is the difference between the fuzzy set as well as the crisp set. I discussed about how the membership functions are defined. Even I discussed about the fuzzy hedges also, the regular fuzzy hedges which we used to use in our daily life using the membership function, how it intensifies and how it weakens the priority of the word depending upon the context. Now, let me discuss about the fuzzy neurosystems. What is the need of this fuzzy neurosystem? So, Neuro-Fuzzy system consists of two different words. One is the neuro. Neuro means the neural network in artificial intelligence. And another one is the fuzzy system. Already we have discussed this part. And neuro means that term comes from the biology. It is a biological term. Actually, it is related to human brain. Our human brain consists of billions of neurons. Especially, neurons are used to accept the input and it processes it as well as it provides the output. Suppose somebody will slap you, definitely what will happen, our neurosystem can understand somebody has slapped me, then definitely that means that understanding is nothing but the processing by the neuron. Then we will take the necessary action. So that is why neuro, it is a word, it is related to the biological neurons which is present in our human brain. But as the subject is applied artificial intelligence or artificial intelligence, you take anything, neuro word is related to neural network. Those neurons, here also neurons are used, but not biological neurons. The neurons are nothing but the artificial neurons. Same artificial neurons, the same capability like the neurons which are present in our human brain. They can accept the input, they can process as well as they can provide the output also. So Neuro-Fuzzy system, especially this type of, already we know that fuzzy system can handle the uncertainty in any, like in our daily life, and it can solve the complex problem also. But what is the need of this Neuro-Fuzzy system? Already whenever fuzzy system is simplifying all the problem, then the need of the Neuro-Fuzzy system is to increase the performance of the fuzzy system. And automatically it can learn, the system automatically it can learn and it can adapt to the situation. That is one of the biggest advantage of the neural network that I will discuss when I will move further in this video. So Neuro-Fuzzy system consists of two concepts. One is the neural network and the second one is the fuzzy system. So generally when both the neural network and the fuzzy systems, both neural network and fuzzy systems are used in a combined way, then that is called as Neuro-Fuzzy system. So this type of system is characterized for a fuzzy system where fuzzy sets and fuzzy rules are adjusted using input-output pattern. So already we know what is fuzzy set. So fuzzy set is related to the mathematical set operation where the union can be performed, intersection can be performed, complement can be performed, and the fuzzy controller is consists of the fuzzy rules, the rules which are nothing but which are defined by the experts using if then condition. So fuzzy sets and fuzzy rules, though both the things can be adjusted using input output pattern. So this input output pattern is related to neural network. So neural network, it is a network which consists of various neurons, and neural networks is having the self learning and self adaptability capability. Means it can learn by itself without the human intervention, as well as it can be adaptable to any circumstances, or it can be adaptable to any domain or any situation. So because of that property, the fuzzy set and the fuzzy rules which we use in our fuzzy logic, that both the things can be automatically adjusted using the input output pattern. So that is why neural network plays an important role in fuzzy logic to improve the performance of the fuzzy system. Now, fuzzy system already we have discussed in my previous video. Let me introduce once again. So fuzzy system propose a mathematical calculus to translate the subjective human knowledge of the real processes. So this is a way manipulate the practical knowledge with some level of uncertainty. This set theory was initiated by the mathematician and the computer scientist Loptizade in 1965. It is a form of logic that deals with approximate reasoning. That means why it is called as approximate reasoning? Because the fuzzy logic, it cannot give the exact truth value or exact false value. It will give the approximate value which lies between 0 to 1. That is why it deals with approximate reasoning. It is created to model human reasoning process, what our brain thinks or how our brain understand. The same way fuzzy logic also understand, which is used in the machine, and it tries to find out the corresponding degree of truth by defining the membership function. And it uses the variables truth value between 0 to 1. Then come to neural network. So neural network, it is a simplified mathematical model of brain-like system. So functions like a massively parallel distributed computation network. Why it is called as massively parallel distributed computation network? First of all, our neurons which are present in our human brain, they are huge in numbers. It is uncountable, billions of neurons are there in our human brain. Same thing, artificial neural network consists of various neurons which are connected with each other. All are connected. As well as that is why it is called as massive computational network. That means this type of network, they can perform the complex type of calculation, or it can solve the complex problem. And parallelly distributed, that means as all the neurons are connected with each other, if any neuron fails at any point of time, other neurons which are connected, they can take over the failed networks work, and they used to resume their work, and they do not stop. They never stops. That is why it is called as parallel distributed computational network. It is not programmed, but it is trained. The neural network, the artificial neural network, no need to program. Once the algorithm is defined, then it should be trained with the data set. Now it should not be programmed again and again. So that is the features of the neural network. Neural networks are a subset of machine learning inspired by the structure and the function of the human brain. They consist of layers of interconnected nodes. Those nodes are called as neurons that can learn to recognize the pattern in data, as well as they can take the decision, or they can make the decision. So these are the two important properties of each neuron. They can learn. Apart from these two, so many advantages are also there. I will discuss later. So they can recognize the pattern in the data. Pattern means, for example, if we give like 2, 4, 6, 8, 10. So what is the pattern of this data? All are even numbers. That is the pattern. It can take the decision. It can take the decision means it can find the conclusion from that even number. So suppose I'll write x is equal to, it may be 2, 4, 6, 8, 10. So x percentile 2 is equal to 0. So reminder would be 0 means all all belongs to the even number. So that, like that type of example, it can take care, means it can recognize the pattern in the data as well as it can make the decision. This is the smaller, like very easy example I'm giving. So many complex things are there. So complex problems can be solved by the artificial neural networks. So every node in the neural network, it can perform 3 different actions. One is it takes the input. Using some function, it can process it. And third one, it can generate the output. Okay, as our human, the biological neuron also does the same thing. They can accept the input from the environment using through the sensor. Same thing here. Artificial neuron, they can accept the input. They can process it using some function. Then they can generate the output also. This is what the picture of a single neural network, single neuron, not neural network. I'm talking about a single neuron, a single node. For example, I will show you in the next slide how the neural network looks like. Let me show you first so that we'll come back. This is the picture of the neural network. Here, the circles are nothing but the neurons. Each circle, this is one circle, this is one circle, this is one circle. So all circles are the neurons. Each neuron is connected with each other. Right? Now let me go back to that screen so that we are discussing about a single node. We are talking about a single neuron, how it looks like and what is its functionality. Right? So this is a single node, or it is also called as neuron, or else it is called as artificial neuron. So each artificial neuron is divided into first it is divided into 2 parts. So first part is the summation and second part is F, it is written. Here you can see, if you consider the total, it is a single neuron. Right? So each single neuron, it is divided into 2 parts. One is the summation function. Second one is F, which is nothing but the activation function. This is summation function. This is summation function, and this part is activation function. This is activation function. 2 functions are there. One is summation function, another one is activation function. Now you can see this picture. Here, x1, x2, x3 up to xn are nothing but the inputs are provided to the neuron, right? So each single node. So x1 is associated with w1, x2 is associated with w2, xn is associated with wn. So w1, w2, w3 up to wn are nothing but the weights. So W1 is associated with X1. So each input means X1 is associated with W1 means each input is associated with the corresponding weights. So why the weights are required here? Suppose this is one neuron and this is another neuron. They are connected with the help of one connection link. That connection link consists of some weight. That weight may be W. Why this weight is required? Weight means some value. Some value it should be assigned for this connection link between the 2 nodes. So that W defines the strength of interconnection between the 2 neurons or 2 nodes. So that is what W are used, W1, W2, Wn. Next, all these inputs along with their corresponding weights are provided to the summation function first. So summation function, what it does, it adds all the inputs together. How it adds? Like first it multiplies x1 w1 plus x2 w2 and up to dot plus xn wn. So it multiplies each input with their corresponding weights and they perform the addition. So who performs this one? Summation function performs this one. Then after this, after performing the summation of all these inputs along with their weights, then the output is provided to the activation function F. The activation function, what it does, basically this normally in machine learning, activation functions are used to define the non-linearity into the model. Means whenever the situation is very complex or the problem is too complex, we cannot solve using linear equation. In that case, we can add the non-linearity into the model. So that is why activation functions are used. So activation function, it accepts and performs the activation and finds the output. So that is what the each neuron works in a neural network. And here you can observe one of the small b is written. B is nothing but the bias. Bias, what is the meaning of bias? Bias means small amount of small value, we can say. Okay, so small value which ranges between 0 to 0.5, that value, it gets added or it is given to the summation function to adjust the output. How to adjust the output? What is the meaning of the adjustment of the output here? So each neuron, whenever they accept the input, processes the input using the summation function and the activation function and generates the output here. The output which we get from the network, that may not match with our targeted output or approximation output. If the output which we get from the neural network, if it does not match with our targeted output, that means that much error will be generated. So to minimize that error between the output which we get from the network and the targeted output, we used to adjust or we used to add some bias to the inputs, so that the error between the targeted output and the original output will be minimized. That is why the bias is used in computer neural networks. So this is the description of a single neuron in artificial neural network. Now let me move forward here. Then the neural network, it can mimic the basic functioning of the human brain. Already I have discussed how our human brain thinks, perceives, then generates the output. Same thing, the artificial neural network, they can mimic like the basic functioning of the human brain. It can solve the various real-time tasks and the complex problem also. It can perform the computations very fast compared to other techniques, and it can provide the fast response compared to other machine learning algorithms. Huge number of interconnected processing elements are there in the neural network, which are called as the nodes or the elements or the neurons, we can say, or artificial neurons also we can say. And all the nodes are connected with the help of connection link, and the connection link consists of weights. Just now I discussed in the previous slide how each neuron is connected with another neuron with the help of connection link, and each connection link contains some weights, and that weight represents the strength of interconnection between the two nodes. There are various tasks can be solved using the artificial neural network or by the neuron, especially the classification problem like segregation of the mail into spam mail or non-spam mail. There is one of the classical example of the classification problem which is used in machine learning. Even it is also used in the pattern matching. It is used in data clustering. Pattern means like what type of pattern. Like if we just now I have given one example 2, 4, 6, 8. So all are even number. That type of pattern it can find out. It can take the decision also, as well as it can also be used for data clustering, segregation of the data points into different sectors based upon their similarities and dissimilarities. So all these tasks can be performed by the neural networks. These are the various components of the neural networks, like the neurons. Each node is called as a neuron. Already I have discussed in this video. And next one is the layers, weights and biases, activation function, forward propagation, loss function, backward propagation. Why I am discussing all these points? If you understand the concept of neural network, then it would be easy to understand Neuro-Fuzzy system. Already we know that Fuzzy system. Just I am describing what is neural network, how the neural network works. Then I will combine both the concepts together to understand the Neuro-Fuzzy system. So this is the concept of neuron or each neuron. Already I have discussed in the previous slide. It is the fundamental unit of neural network. It takes the input, process them through an activation function, then produces the output. So this is what each neuron looks like. Each neuron is divided into two parts. One is the summation function, another one is the activation function. The summation function takes all the values, all the inputs x1, x2, x3 up to xn along with their weights w1, w2, w3 up to wn. These are the weights. So weights defines the strength of interconnection between two neurons. So summation function it finds the sum of all the inputs along with their weights. First it multiplies the input along with their weights, then it finds the sum x1 w1 plus x2 w2 plus x3 w3 up to xn wn. Then that output will be provided to the activation function f. So here the activation function, it activates to implement the non-linearity into the model by using different activation functions are there. So, and it generates the output. Here the output would be y is equal to f of xi wi. This is a simplification of this particular node or the neuron. Now, second component is the layers. In our neural network, there are we have three layers. One is the input layer, second one is the hidden layer, and third one is the output layer. And each layer consists of various neurons or a number of neurons. Each circle is called as a neuron. This is one neuron, this is one neuron, this is one neuron. Similarly, hidden layer also consists of various neurons and output layer also. So each neuron of one layer gets connected with the neuron of the next layer. That means especially this neuron is connected to this node, all the nodes of the hidden layer. Same thing, this node, the second node also connected to all the four nodes of the hidden layer. Same thing, third also it is connected to all the nodes of the hidden layer. So that is the representation for the interconnection or the connection between each node. So what it says, each node is connected with other node. Especially each node is connected with each node is connected with all other nodes with the help of the interconnection link along with their weights. And similarly, all the nodes of the hidden layer are connected to the output layer. Now, the input layer is responsible to take the input from the environment. Then that input will be processed and will be forwarded to the hidden layer. Hidden layer is responsible to process all the inputs which it receives from the input layer. Then it forwards the output to the output layer, and the output layer is responsible to forward or to provide the final output to the user. But that is not the way every time. As I told at the beginning, every neuron in the neural network is responsible to receive the input, process it, and forward the output. In general, we can say that input layer is receiving, hidden layer is processing, output layer is giving, but that is not correct. Every node is responsible to all the three, like it receives the input, then it processes, then it forwards some or generates some outputs. Every neuron. So whatever the output is generated, that will be propagated to the hidden layer. Then again processing will be done by the hidden layer. Again it receives the input from the input layer, process, then generates the output. Same thing will be passed to the output layer. So every neuron, every node in each layer is responsible to receive the input, process it, as well as provide the output layer. Now, as it is a simple neural network, so it consists of only one input layer and one output layer and one hidden layer. If the situation is complex or the problem is complex, then there can be more than one hidden layer for further processing. But only it should be required like only one input layer and one output layer. We cannot represent more than one input or more than one output layer. Then comes to the weights and biases. Weights are the parameters which adjust the input signal strength. Already I have discussed, each input layer consists of some weights. Each input means the interconnection between two nodes are consist of with weights which defines the strength of interconnection. And biases are nothing but the additional parameters added to the neuron's input to adjust the output along with their weights. Then activation function, which is used to introduce the non-linearity into the model. So there are various activation functions are used like ReLU function, sigmoid function, or TANS function. What is the meaning of this non-linearity of the model? For example, if I write y is equal to 2x plus 3. Now, for every change in the value of x, there would be a corresponding change in the value of y. And if you plot the graph, we will get the graph like this, like a straight line between x-axis and y-axis. But the same case, if I write y is equal to 2x square plus 3, then for every change in the value of x, is there any corresponding change in the value of y? The value of y, it may differ proportionally, it may may differ. Okay, so that is why. So because as it is a complex problem, I'm giving a small example. It may be 3x cube, 2x square plus 5. So for every change in the value of x, there should not be we may not get the corresponding value of y proportionally. So in that case, we have to apply this activation function to apply the non-linearity into the model. Then the fifth component is the forward propagation. Forward propagation means propagation of the error from the input layer through the hidden layer to the output layer. Simple meaning, the process of passing the input through the network to get the output. That is called as forward propagation. Loss function means what? Normally, whenever the input, this is our input layer, this is our hidden layer, and this is the output layer. So whenever input passes from input layer to hidden layer and hidden layer to output layer, that is called as forward propagation. Okay, the reverse case, if it does, like if the error passes or forwarded from the output layer to the hidden layer and hidden layer to the input layer, that is called as backward propagation. Whenever the backward propagation, the next concept I will explain what is the meaning of backward propagation. When this thing happens, if the output which is generated, suppose the output is generated as y and expected output is o, our targeted output is o, and this value does not match, okay, and more variation is there. In that case, what will happen? The error again, it will be propagated in the reverse direction from output layer to the hidden layer and from hidden layer to the input layer. So this, in the gap between the original output which we get from the neural network and our targeted output, that error is called as the loss function. So how the error can be defined? Using a function which is called as the loss function. So various loss functions are used to define this gap between the targeted output and the original output using the mean squared error or cross entropy loss. So a function that measures the difference between the network's output and the actual target value can be defined using the loss function. So as I have already discussed what is the meaning of back propagation, here it is defined: the process of updating the network's weight and the biases to minimize the loss function. This is the picture of the neural network. So this is the input layer, this is the hidden layer, and this is the output layer. We are getting the output at this output layer, we are getting the output y1. At this neuron, we are getting y2 and yn. And this value, suppose our targeted output is o1, o2, and on. If it does not match, then the error will be propagated in the reverse direction. So that is why the signal I have given over here. So that terminology is called as the backward propagation. So up to what time the error will be propagated here, like forward and backward, until both the outputs like y1 and o1 are approximately equal, means they are closer to each other. Then only the error will be propagated and the process will continue both forward and backward propagation. So it uses the gradient to propagate the error back through the net. Now let us discuss about the Neuro-Fuzzy system. So Neuro-Fuzzy system, as I have discussed the clear idea about the neural network, and already we know the Fuzzy system. If we combine both the things together, then that is called as the Neuro-Fuzzy system. Especially it is used to increase the performance of the Fuzzy system, because development of the Fuzzy system with good performance, it is not an easy task. That is why neural network algorithm can be applied to the Fuzzy logic. So the neural network that have efficient learning algorithm has been presented as an alternative to automates or to support the development of the tuning Fuzzy system, where the performance can be increased. So Neuro-Fuzzy system in artificial intelligence combine the neural networks and Fuzzy system to leverage the strength of both the approaches. To leverage the strength of both the approaches means the approach of neural network as well as the Fuzzy system. So they are widely used in the complex system where precise mathematical modeling is very difficult and impractical. These are the key concepts of the Neuro-Fuzzy system. Already I discussed when I discussed about the Fuzzy logic. First key concept of the Neuro-Fuzzy system is Fuzzy logic. It is not a logic, but it can handle the situation which is fuzzy or vague. That is the Fuzzy logic. Neural network, it is a learning algorithm, we can say, in machine learning, or it is a subset of machine learning, we can say, which is having the self-learning and self-adaptability capability. And Neuro-Fuzzy system is a combination of both the concepts, Fuzzy logic and neural network, which can increase the performance of the Fuzzy systems. Then how Neuro-Fuzzy system works? So basically, the Neuro-Fuzzy system works based upon these 5 components. First one is the fudgification, then rule-based, inference engine, defudgification, and learning mechanism. When I discussed in like fudgy logic control video, I discussed these 4 components already. I discussed in our fudgy logic control or fudgy logic architecture. So fudgification means what? Which converts the crisp value to the fudgy inputs. Then those crisp input means the value which we can represent in the form of real numbers, which cannot be processed by the fudgy controller. Then rule base, it is a knowledge base where various rules are defined by the experts, and inference engine is used to match the inputs or the fudgy inputs with the knowledge base or the rule base to identify how many rules are matching. Based upon that, the rules will be fired. And defudgification is the reverse process of the fudgification. So defudgification, what it does, it converts the fudgy outputs to the crisp output so that user can understand or the machine can understand. And this is the last component, which is called as the learning machine mechanism or the learning algorithm, which we get from the neural network. Because neural network, it is a machine learning mechanism which is having the self-learning. Automatically it can learn from the data set, as well as it can be adaptable. No need to teach, no need to one time we need to train. Next time onwards it can learn, and it can be adaptable to the situation, and it can perform the action also. So these are the various key concepts of the fudgy system, Neuro-Fuzzy systems. Now let me discuss different types of models of the Neuro-Fuzzy system. Basically, there are 2 types of models are there. Though we are using the neural network in fudgy system, sometimes we can apply the fudgy output to the neural network, or else we can apply the input to the neural network. That output of the neural network can be provided to the fudgy system. In either case, anyways, the performance of the fudgy system can be increased. So this is the pictorial representation of the first model, first Neuro-Fuzzy system model, where the fudgy inputs are provided to the neural network. Now you can see in this diagram, the linguistic statements are called as the fudgy edges, which will be passed to the fudgy interface. Here the linguistic statements are nothing but the crisp inputs will be provided to the fudgy interface to convert into their perception as neural inputs. So these are nothing but the fudgy outputs, or the outputs which are coming from the fudgy interface are nothing but the fudgy outputs. These outputs are called as the perception as neural inputs. Why it is called as the perception as neural input? Because the fudgy here this is the crisp input. This is the crisp input, and crisp input, whenever it is passed to the fudgy interface, it will provide the fudgy input, right? So fudgy input. So fudgy input are called as the perception as the neural input, because this input will be provided to the neural network now. So that is why a neural network will perceive the fudgy input. That is why these are called as the neural inputs to the neural networks. So when the neural network receives all the fudgy inputs or the neural inputs, then what it does, it will learn automatically, as well as it will be adaptable to the situation, as well as it takes the decision also. That means it provides the output. But whenever it provides the output, it may be correct or it may be wrong. So depending upon, it is not a single process, it is a continuous process, a cyclic process. Continuously it goes on. So depending upon again the fudgy input, it takes some decision. Like this, the process goes on. As well as while taking the decision, the learning algorithm which is given or which is used in the neural network, that can learn by itself all the inputs, as well as it can provide the output also, right? So this is the way the first model it works. Like the fudgy inputs are passed to the neural network to take the decision. While taking the decision by the neural network, the learning algorithm can learn, as well as it can adaptable to the situation also. This is the second type of model, where the neural inputs are provided to the fudgy system. Here the initial inputs are called as the neural inputs, which are provided to the neural network. Then neural network provides the neural output. The neural output will be provided to the 4G interface to take the decision. While taking the decision by the 4G interface, the learning algorithm is used by the neural network gets updated. That means it will learn from the data from the decision as well as try to update the knowledge base also. Here the knowledge base, which consists of lots of data and the rules provided by the experts. So when the database gets updated, when the learning algorithm tries to update the data, that updated data will be updated in the knowledge base also. But in the previous case I discussed, there is no knowledge, though knowledge base is there, knowledge base does not update. But here but in this case, knowledge base will be updated as whenever the decision is taken by the 4G inference system. So this is how the model works in both the cases in 4G neuro system. These are the applications of the 4G neuro systems. Basically, all these 4G neuro systems are the advanced concepts in 4G logic. It is used in the control systems, especially the microwave oven, the refrigerator, the AI controlled washing machine, AI controlled air conditioners. Even it is also used in the medical diagnosis to increase the performance of the medical expert systems or medical 4G systems. It is also used for predictions as well as the forecasting. Predictions means market price prediction. Even it is used for the weather forecasting also, as well as it is used for the robotics also. So this is all about this particular video. So for the preparation of this video, I have referred the book Soros Kosik for Artificial Intelligence, as well as I have referred the website which is available on the screen. I hope you might have enjoyed this video. This is all about. So let me stop here. So till then, take care. Thank you. Bye bye.
Like, share and subscribe. Hit the bell icon for more updates.